Oh man, we only get one panel today. Darn it. Come on. Hopefully the other one will. Dang it. That's oh. I was hoping. Okay. Today is kind of a sleepy day today, isn't it? I feel like campus is like really just very quiet. So exciting news this week. We got big things happening. You have your grades coming in. So woohoo! TAs have let me know that they have finished grading your exam 1. So as soon as I check those, when I leave this class today, I will be able to inform you of your exam 1 grades. You will also be getting quite a few of your other grades, so you'll know exactly where you are in the course. I'm sure you all will be super, super happy about that. And the other big news is who knows what else is happening this week? Yes, sir.
Exam 2.
Oh yeah, exam 2. So no surprises. It will be like your last exam 1, so don't forget to turn in your scrap paper after you've completed your exam. Your exam will be 10 questions designed for 1 hour, so you're going to want to make sure you budget your time per question. You're given quite a bit of time per question because I don't know if you all know this, but if you took the FE exam, you'd be receiving much less time per question for that. So on these standardized exams across the United States, employers do expect you to be able to, solve these pretty quickly. So I'm trying to get you in the habit of studying and being efficient with your problem solving. Have 15 extra minutes to resolve any kind of honor lick issues. So do make sure that you have used your practice exam 2 to figure out any of those issues. Yes, sir.
How come in the practice exam there's only 5 questions, yet the exam has 10?
What says 5?
The practice exam.
Because it's just, if you read the description of it, it says it gives you a few sample questions. So it's not a full length exam.
Oh.
So it gives you a sample of the types of questions you might see, and it gives you a sample of all the resources you're going to be given on the exam.
I'm just wondering because the last practice exam was a little bit longer and this was a little bit shorter.
Yeah, because it's only meant to be like sample questions. So you have an idea.
Okay.
So it's not a full length exam because I didn't think you all would want to be tortured for that long twice. So you do have some example questions of what might appear on the exam. And you definitely want to use it to settle any honor lock issues. The one thing I will say is, like I recommended last time, please hang out on the exam, the practice exam for a while, just to make sure nothing, is a surprise. So, certainly make sure you know what happens if you're, opening your browser or you're moving your mouse or you have your scrap paper in front of you. You want to make sure you can show it to the camera well. You want to make sure that your lighting isn't going to give out on you and do something weird with the camera. So please hang out on that practice exam so there's no surprises the day of the exam. And who can tell me what's going to be on the exam? Did anybody check out what's available in your module for exam 2? Anybody know what we're doing? Make sure that. All right, so let's check it out for a second. So many different things. All right, so if you have checked out your exam 2 module, please make sure that you check out the format. It's going to tell you what sections on the exam. Does anybody happen to know offhand? Anybody looked at it yet? Yes.
Vectors, cofactors, minors. Looking if a matrix is invertible.
Oh, good job, yes.
At joints.
Yeah, we've got a good handle on some of them already. So there's going to be quite a few things you're going to want to look through. So it's going to be sections 2.1, 2.2, 2.3 of chapter 2. So the complete chapter 2, but then chapter 3, we're only going to do some of the sections. So section 3.1, 3.2, and 3.3. So today we're going to be working some problems. And today we'll give you a chance to see if you can earn any bonus points for your exam too. So you want to hang out with me today till the end and see if you can earn your team some bonus points. All right. We have, let's see, where did my textbook go to? All right. Bum-ba-dum.
Question?
Yes, sir.
Last week we did like a team assignment thing. Who got first?
Who got first? Oh, that's right. Many of you actually solved it. So I will tell you at the break who got it right. So there was quite a few teams that got them all. So if you solved all 3 messages, priority of winnership will go to those who are able to finish it within class time. So we'll see I'll check that out during break and let you know. Let's see. Now, today, we are looking at vectors. So hopefully you have gone ahead and reviewed your content videos.
I'll check out wrong.
And we are going to be looking at some different manipulations of vectors. I'm sure that you guys have probably done vectors in many of your courses. I will say that you always kind of want to recognize that different fields in mathematics or in the different sciences and different engineering, they might explain vectors in slightly different ways. They might have slightly different notations. So you'll probably notice a couple differences with this textbook. But keep in mind, a lot of principles obviously will hold true. Let's see here. So we're going to go ahead and we're going to jump to the end where we're going to go ahead and work some of our problems. And we'll look at that. So don't forget this, like stuff like this, you're going to have to be aware of your properties of how you can manipulate vectors. You're going to want to know what this means. You're going to want to hint, you want to make sure that you are familiar with your theorems because you may need to go ahead and verify if any of these properties hold true. So that's nothing new. You've done that before on your other exam. And we're going to go ahead and jump on down. So we have some different problems that are in your course schedule. So we're going to go ahead and check that out today. And we have for section 3.1, we're talking all about figuring out our different components of our vectors. So let me just ask you, if you were faced with a diagram like this in problem 1, what can you tell me about that particular vector? Anything that you remember from this particular section? Anybody remember? Like, what would we call the coordinates 1, 5? According to this textbook. Yes.
I don't know if that's correct, but wouldn't it be OP1?
Okay, yeah. So if you drew then from the origin to that particular point, that might be OP1. But those coordinates 1, 5. What does this represent, this point here? For this particular vector. Yes, sir.
The origin of the vector?
Yeah, we call that also, it's not at the origin, right? But what would we call that? According to this textbook, their terminology. Yes.
Initial.
Oh, you got it. Yes, the initial points. So then you have here this other point that describes this particular vector, 4, 1 coordinate. What would this be? Yes. Oh yeah, that's the terminal point. Okay. So if we are going to then use those terminal points and initial points of this vector to find the components of the vector itself. So how would we go about doing that? Boy. Tell me, how would we find, it's asking us for this, how would we find the components of this vector? It's given us the initial point, it's given us the terminal point, neither one of them are at the origin of our coordinate system. So how would we have one set of components to describe this vector? Yes, sir.
The terminal point minus the initial point.
Yeah, you got it. All right. So if we go ahead and look at that, what do we have? We have 4 minus 1. We get 3. And then we have 1 minus 5. We get -4. What is that telling us about this vector? Why would 3, -4 be the components of this vector? And conceptually, what is that telling us? If you look at it, what's happening with it? Why would 3, -4 describe this vector? Like really boil it down to its kind of its basic visual. Yes, go ahead.
Slope.
Yeah, so we're looking at it where this particular vector is 3 units in the positive direction and 4 units in the downward negative direction. Yes.
It gives us the same angle as if it started from the origin point.
Okay. So yes, there's that. You have that same angle as well. So let's go ahead. And so these are types of problems, if I give you on the exam, this would not take like the whole 6 minutes, right? I would anticipate that you could do something like this in your head and be able to get to that answer pretty quickly. So then you'd even have even more time for your other questions. So not all, you have to think on the exam, not all questions take the same amount of time, depending on how much you study and how much you can go ahead and calculate quickly. So be aware of that. All right, if we looked at B, who can do this one really quickly in their head? What would be our components for B, part B? And let's see, Cody had it, yes, positive X, negative Y direction, excellent. And it looks like Alejandra had it for initial points. Let's see, yeah, we're gonna be talking about the norm later for sure. Yeah, it gives us a sense of direction. And it looks like Cody has in there 5, 0. Let's see, so if we look at part B, what would you guys say really quickly on that one? You'd have to locate what? Your initial point really quickly. Here it is. This time, your terminal point is way up here. So who can do that one pretty quickly in their head? Yes.
-2, -3, 4.
Ooh, all righty. So see, all right, -2, -3, 4, boom. Okay, let's see what was our next one we had to get done. All right, so we'll get through some of these. And what do we got? We've got, let's check out problem 2. Okay. Let's see what we got for that one. Well, this is kind of more of the same, yes? Would you agree? They're asking you to find the components of this particular vector. You have to kind of pay attention to how many components it has. So let's go ahead and we'll jump to exercise 3, which was the next one we had to do. Okay, so here in exercise 3, it says find the components of the vector P1, P2. What does that nomenclature indicate to you? If you have it written like this, vector P1, P2, what does that tell you?
P1's the initial.
Yeah, exactly. So that this arrow is giving you the direction of that vector. It's telling you that P2 here is your terminal point, P1 is your initial point. All right, so these are more quickly you could do in your head. So what would be our components of 3A? All right, go for it.
-1, 3.
You said what for part A?
Yeah.
Okay, got -1. You said 3? Okay. Yep. Here we go. All right. What about part B? Who could do that one really quickly? Yes, sir.
-3, 6, and 1.
Okay. -3, 6, and 1. Okay. Boom. Awesome. So what we're doing, we're just basically subtracting that initial point from the terminal point. So 4 is going to be very similar. All right. We're going to be looking at number 5. What does that want us to do? Ooh. All right, 5. It says find the terminal point of the vector that is equivalent to u equals 1, 2, and whose initial point is a, 1, 1. So they want us to find the terminal point in this one. A little bit different now. So they're giving us this time the initial point, and what else are they giving us in this particular problem?
A unit vector?
Yeah, they're giving us the actual vector u, telling us it's equivalent to that. So those would be the components of this vector. So we're solving for the terminal point in this instance. So how would you go about doing this one? How would you set that up? Our what would we be setting up there for number 5? Yes, sir.
We have the initial point plus the terminal point equals u. Solve for the terminal.
You're saying the initial point plus the terminal point? Which one's minus what?
Oh, yeah.
But tell it to me one more time.
Plus,
So what would be plus?
if the terminal point was b, it'd be
Uh-huh.
not a plus b equals u.
What do you guys think? Do we? You have a,
No, you take the terminal, the formula is terminal minus initial equals the vector. So then you add the initial to the other side. Well, no, you add, what point do we have? We add the initial to the other side, and then you can get the terminal form.
okay, what do we think now? What you have, I think we had some other thoughts. Anybody else?
I agree with them, but I think it's simpler to just add the unit vector to the initial.
Okay. So you're saying just add u to initial? Okay, I think you had some thoughts too.
You can either do it the same way he said, like add it, or you can do like B1, B2, and then do like B1 minus 1, and then.
Okay. Yeah, so a couple different ways you could do it. So we'll go ahead and check this out. So according to this, you have to kind of designate your terminal points. So in this case, they're calling the terminal point B, and it has components B1, B2. So we gotta, it has to satisfy the equation where here you got the terminal point minus your initial point is gonna equal your components of your u vector. So you can see here B1 minus your initial point from A equals 1 from your u. And then B2 minus 1 equals 2. So you can kind of think about it how you also had described it too. You could go ahead and basically rearrange that as well. You could describe that also as your u plus the initial point. But either way, you should go ahead and get your terminal point as being 2, 3. So does everybody see that? So you'll want to make sure that when you're talking about a vector and its components, you'll be subtracting the initial point from the terminal point. Okay, so let's see who can do. There's another one that's very similar. This one says for part B, the initial point of the vector that is equivalent to u equals 113 and whose terminal point is B. Uh-oh, they switched it up. Now what are we going to do? Yes.
You can do B minus U equals A.
Oh, okay. Anybody else? Any other ideas? Agree? Disagree? So you'll want to make sure you read these problems carefully because hint, hint, you might have a question like this on the exam. All right, so we go ahead and look at this. So we find out we have the initial point. This time this is the one that we don't know. All right, we do know the terminal point. So we know that the first component of the terminal point minus the first component of the initial point will give us our u. And that first component of u is 1. So -1 minus a1 equals 1. Then we know that the terminal point, second component, -1 minus a2 is going to give us this second component of u. So we got -1 minus a2 equals 1. And then for our third component, we have our terminal point 2 minus our a3 is going to give us the third component of our final vector u. And so we end up with solving for all of that, and we get our initial point is -2, -2, -1. So do make sure you're very careful about when you read these. Did you get given the terminal point? Did you get given the initial point? And so on and so forth. So let's look at really quickly. We're going to look at number 7. So who can tell me what they think about number 7? This one says find the initial point P of a non-zero vector PQ with a terminal point Q, so giving you that terminal point, such that U has the same direction as V. Oh boy. Trust me. So we have terminal points. This time, instead of giving us U outright, they have told us that U is in the same direction of V. So how would you handle that question? What do we know about U then? Yes.
I'll do the terminal point minus V.
Okay. What do you guys think? Terminal point minus V? Why would we do that? So we have some other suggestions in the chat. Looks like Milton said set U equals V. What do you guys think about that? Why might you do that? Yes.
Those are the same direction, so U
Yeah.
would be.
Yeah, so U, if we wanted to be really technical about this, how would we describe U? It equals what? Well, so in one instance, it could directly equal V, but if you were to just in general describe U,
Scalar multiple of you.
yeah, so U would equal KV, right? And so for this particular problem, though, we would go ahead and for simplicity's sake, you could make the assumption then, well, for this instance, we're going to assume that K equals 1 so that U equals V so that we can go ahead and solve. But let's go ahead and check it out. So for any positive real number K, the vector U equals KV. So that's going to be a really important also distinction here because to be the same direction, it has to be a positive real number K, so non-zero. All right, so they're in the same direction as V. If we decide to go ahead and let K equal 1, we can set U equal to V and U equals 4, -2, 1. And then we know the terminal points. And so we can go ahead and subtract our U from our terminal point to be able to find our initial point. So hopefully that's something that you can go ahead and also do in your head. But let's take a look at B. So what do we think about B then? Now, what do we assume U is? Yes.
We would assume K is -1,
Okay.
in which case U would be -U.
Okay. So this is oppositely directed. So in generic terms, U would equal -KV, right? And then we're going to go ahead and assume, let's let K equal our -1. So here, if you went ahead and solve that, here you'd have this time U equals -4 to 1. And then you have your terminal point here, 3, 0, -5. And so then from there, you'd be able to solve for your initial points by subtracting U from Q. So hopefully you get 7, -2, -6 for your answer for your initial point. All right. So all of this is pretty easy, right? Or is it hard to visualize? Let me know. What do you guys think? You guys are feeling pretty confident? Anybody have any questions on any of these? Feeling pretty?
Could you choose any K? Or would you still?
Exactly. So just realize we are making that assumption, right?
Yeah.
K doesn't have to be 1 or -1.
There's like multiple.
So you could have multiple possibilities, right?
Obviously.
So you might even write your answer for your initial point in terms of K, right? If you wanted to leave it general and be able to then solve for any K. So there's a couple ways to think about this. So I've had some people do that on the exam. They've gone ahead and assumed a K to show their points, or they kind of left it in a general sense where U could equal -KV or U could equal KV, and then left those K terms in there to be anything. So keep that in mind. All right, so let's see what's our next one on the agenda. Okay, we've got, I think it was number 10, I think was the next one I had listed. All right, so number 10, I think this is something that you guys can all handle. We're going to look at 11 so that it easily shows us things. Let's catch up with our online folks. Looks like they're doing okay. All right, so let's look at number 11 here. It says let U equal -3, 2, 1, 0. V equals 4, 7, -3, 2. W equals 5, -2, 8, 1. Find the components of V minus W. All right, so tell me about addition and subtraction of vectors. What do you do for that? So for that first one, A, and you're asked to subtract W from V, how would you go about doing that? From this particular section. Yes, sir.
We will subtract each individual component.
Mm-hmm. So once again, this would probably be a question that you could easily finish in quite a bit less than 6 minutes. So anybody want to try to do this in their head? V minus W?
9, -11, 1.
Oh, okay, let's see what we got. -1, 9, -11, 1. All right, so you're moving on in your exam. All right. Any issues with B? What is it asking us to go ahead and solve for first? How would you work through this order of operations? For B? You got an expression like this.
Scalar first.
Okay, so 4 times W. I think you had your hand up.
I was like work on the parentheses first, but
Okay.
it's 4 times W, then after that, Y minus whatever the answer is for 4W.
Uh-huh. So how would you multiply 4 times W? What would that look like?
That's not how to say without writing it down. Wait, am I actually writing it on the board or?
Oh no, you can just talk out loud. So what does that mean for W? How would we get that?
Yeah, 4 times 5, -2, and 1.
Okay, so if we did 4 times W, we'd be multiplying 4 times
And
Each component.
each component, right? Yeah, so you'd have to do 4 times 5, you'd have to do 4 times -2, you'd have to do 4 times 8 and 4 times 1. Then what would you do?
then I guess Y minus whatever the component is, 4W.
Yeah, so we'd have 4W and then we would
And after that,
yeah, you got it?
yeah,
Got it?
yeah, after the, well, you want me to tell you what it is, or when,
No, just what you would do.
well, once I found the component, then I subtract B component minus 4W component.
Yeah, exactly. All right, so that would be your next inside the parentheses. And then your next thing to do would be to add to -U. So you'd have to make sure that you did what to U first.
Negative times the component of U.
Yeah, you'd have to have the opposite direction of U, so you would change the sign on each of these components of U, right? So make sure that with these that you follow your order of operations, make sure that you know which comes first. So for instance, for number C, you would want to obviously multiply 3 times your V. Whatever that happens to be, you would subtract it from U. Whatever that quantity happens to be, then you're going to multiply each of those components by 6. So I think that you guys, any troubles with any of that? Simple vector addition, subtraction, scalar multiplication, not too bad. How many of you have seen this many, many times already? Yeah, nothing new? Okay. So let's go ahead and we will look at, let's read on from that section. All right. Ooh, let's see what we have for let's look at number 19. Okay, so if we look at number 19, it says find scalars C1, C2, and C3 for which the equation is satisfied. Oh, so now we're starting to get into some more concepts here. What the heck is happening in 19?
A linear combination, right?
Exactly. What's a linear combination of what?
That is a linear combination of 3 other vectors by
Yeah.
3 scalars unknown.
Yeah. So what does that start looking like that we've done before?
Kinda looks like a linear systems of equations.
Yeah, it certainly does.
We only got one.
You only have one.
Is it? We only have like one equation.
Oh, do we? How would we represent this as a linear system? So if we look at this, that vector, -1, 1, 19, right? That is a linear combination of those other 3 vectors, right? By those scalars, C1, C2, C3. And that might very well help into you in your different engineering applications, right? You might have to be able to add up different vectors. And you might not know what these scalars are. So how in the world, based on what you know of chapter 1, how would you turn this into a linear system? If you know that vector is a linear combination of these other three that are, yes.
I would make the first components of each become the first row in a matrix, and the second be the second row, the third be the third row, with
Okay.
our B matrix being what's on the other side of the equal side, which would be -1, 1, 19. And we use that to solve for C1, C2, and C3.
Ooh, so are you going to use a coefficient matrix? Are you going to use an augmented matrix?
And
How many equations do we have as well?
an augmented matrix with 3 equations.
Oh, what do you guys think? You like that idea? Anybody has any other ideas? Oh, look at Cody is writing them all down in the chat. Okay, so let's see what happens. Dun, 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 dun. All right, here is your vector equation. This would be equivalent to this linear system. So good job, Cody. Looks like you've got it. When I go ahead and compare. All right. So if you look at this, here we would have our 3 equations, and our C1, C2, C3 is our 3 unknowns. All right. So you can see here that the 1, 3, 0, and -1, those are all referring to like your first components of all these different vectors. So we have 3 equations, like you said. We have, we're going to be using an augmented matrix to solve. And they've gone ahead and done that for us. How nice of them. And they've got it down to the reduced row echelon form. And so how do we directly interpret this particular matrix if you get something like this? Oh, they give you the answer right there, don't they? But if you just were to see that reduced row echelon form, you'd be able to easily see what? Like a 1-to-1 correspondence there.
Yeah.
So you'd have C1 equals 2, you got C2 equals -1, C3 equals 5. So hint, hint, you might have something like this on the exam, where now you have to actually relate your vectors to how that might be part of a linear system. One of your vectors might be a linear combination of others. You'd want to find that relationship between them all and solve for these scalars. All right, let's see what else we have. Anything else that's interesting from this particular chapter? Ooh, okay, so I think we'll go ahead. Anybody have any questions about that? Because those are kind of some major points. It's a very kind of easy section, right? Anybody having any questions about this? Chapter 2 and chapter 3, I have to say, will probably be the last chapters of kind of like your basic concepts, because chapter 4 starts to get into some really interesting abstract stuff. So we're probably like, once we get these basics down, now we're really going to be working with some interesting information. So, okay, well, let me know. Let's see. Let's see. Yeah, so you can certainly do other things. You could do back substitution. You don't have to necessarily even go all the way to reduced row echelon form. So Milton has some other suggestions. This makes it very easy to see what the answer is, but like if you only went to row echelon form, you could certainly, use back substitutions. So be thinking about some of those other methods you could do to solve that stuff. All right, so let's go ahead and we'll jump to our next section here. All right, so 3.2 is all about the norm, dot product, and distance. So who can tell me what a norm is?
Magnitude.
Oh, good job. Is it a positive or negative number?
Positive.
Always positive, yeah? Okay, what is the dot product? What's the dot product good for? Why do we care about that dot product?
Tells you how I forgot the other collinear. Tells you how collinear
Okay.
parallel they are to each other.
Oh, interesting. And tell us whether two vectors are parallel or perpendicular. Interesting. So in a general sense, what does the dot product tell you? Tell you two cool things. Or you can use it to help you find some interesting things. Oh, good job, Cody. Cody says the angle between two vectors. Does that ring a bell? You might need to know the angle, the exact angle between two vectors, so the dot product is going to certainly help you out. But then also the dot product tells you something else about your vectors. So it can certainly tell you if they're parallel or perpendicular. But if they're not those exact things, what is the dot product kind of telling you? Think about it kind of in conceptual terms. What's that dot product letting you know? This is something you might want to know for whatever application is you're using. It's very connected to thinking about the angle between two vectors. What does the angle between two vectors tell you?
Thinking about the sign, but I think that's what we want.
No, you're on the right track. Definitely. So your dot product tells you how closely angled your vectors are. How similarly directed are they? So maybe these two vectors, like this, are very similarly directed. You have a dot product that's like way off like this, they're going to be very much in opposite directions. So it's giving you an idea of how similar the direction is between the vectors that you're considering. So we care about it a lot for different applications. So if we look at, let's look through some of these. Let's look at number 1. It says find the norm of V and a unit vector that is oppositely directed to V. What? Okay. What the heck is a unit vector? Why do we care about it?
Unit vector has a length of 1 and it's pointed in the direction of the positive axis on each axis.
So that would be a standard unit vector. So very good. So you're almost, but if you just had a unit vector.
The norm is 1.
Okay.
Vector with a norm is 1. I think that's really it.
So why would we want like a vector of norm of 1? What's that helping us do? Yes.
Comparisons.
Yeah. So let's suppose you don't care about the length or magnitude of your vector. You're only concerned with direction. Then you just need your different unit vectors because they're going to point you in what direction these things are going. So if you're only concerned with direction and you just need some unit vectors to kind of let you know that, then that's when you might want to go ahead and calculate those. Now, certainly the coordinate system that we are used to seeing uses standard unit vectors, and we have one along X, Y, and Z axis. You might know your standard unit vectors as I hat, J hat, K hat. Does that ring a bell? Now in this textbook, you will notice that our standard unit vectors don't have the hats. So like I said, different fields don't always have the same notation for things. If you go ahead and put hats on your standard unit vectors on your exam, I don't care. I know that you use that in other fields. But just realize there might be some slight differences. Okay, so if we look at this example, we look at exercise 1, it says find the norm of V. So what do we got to do for finding this norm of V? What are we looking for? We're looking for its length or magnitude. We know it's going to be a positive entity. So how do we go ahead and calculate that norm? What did our section tell us? Okay, so Cody says, add all the squares of the components and then square root it. What you guys think? You agree? All right, so that's exactly what we do to find out the norm of V. And then it says they want a unit vector that is oppositely directed to V. What are they going? How are we going to solve for that one? And you have to be careful about what the problem will ask you. It's specifically asking for a unit vector that is oppositely directed to V. So don't forget to notice that important point. So how would we figure out a unit vector that is oppositely directed to V? What's the math there? You guys remember?
Just like 180 degrees.
Okay, yes, it'll be oppositely directed, so you're exactly right. It's 180 degrees the other way. But how do we get to what that unit vector should be? How do we get there?
I
Yes.
would first find
It'd
the
be like 1 over the norm of V
Uh-huh.
times V.
Oh, yeah. All right. Good job. Y'all are been studying. All right, so let's go ahead and look at this. So your norm of V, you will notice that we have the nomenclature in this particular text of the two parallel lines that are indicating the norm of V. So like Cody said, you're going to sum up all the squares of the components and then take the square root. So you will notice that they've left it in square root terms of 2 times the square root of 3. This is just fine for your exam. Make sure that on the exam that you pay attention to directions because Canvas can only read numbers a certain way. So if you have to put in the number all in like a fill in the blank situation, you're going to have to round it to some decimal places and you need to make sure that you put in the number specified. But if it's a problem where you're going to do this on your scrap paper, then it's fine if you want to leave it in this square root form. But like you said, so for your oppositely directed unit vector, so here they're going to go ahead and calculate the unit vector for V first. So it's just like you said, it's 1 divided by the norm of V times V. So we get a messy unit vector here, but this indicates the direction of V. And then since it has to be oppositely directed is what they've asked for, then you go ahead and change the direction and you have all negative signs in front of those components. So good job there. Okay, so let's go ahead and see what else we got for this section. That's going to be pretty important. All right, so we're going to get to our dot product questions, and let's see what ones we had there. Let's look at, all right. Okay, so same thing here with exercises 3 and 4. You're going to want to make sure that you do pay attention to the order of operations here. And so, for instance, U plus V, the magnitude of U plus V is what they're going to be asking for here in A. That might be something you might want to compare that. What do you get for the answer versus the norm of U plus the norm of V? You'll want to make sure that you're really careful here with doing what's inside your symbols before you go ahead and take the norm. So just be careful with 3 and 4 if you face those on the exam. Like for instance, you'll notice here, this scalar for 4C, this is outside the sign for your norm. So be thinking about what that means. All right, so let's go ahead and we will look at something that's a good one. We'll check out, let's check out number 9. All right, so it says find the dot product of U times V, U times U, and V times V. So how might you go about calculating the dot product? What were the 2 methods that this section went over? Anybody remember? So if you had to find the dot product, and it doesn't give you any directions, I'd be curious to see which method you all pick. So let's see. Yeah. So then we have Alyssa's got multiply each component together. Cody says easiest is adding up the components multiplied by each other. What do you guys think? Those different methods. Yes.
There's an equation that's like the dot product is u times v over the norm of u times the norm of v times something.
Yeah. What was that? So there's two different ways to calculate your dot product. So which one would you automatically use for this question? Because it doesn't give you any other information. So it looks like Alyssa and Cody are on the right track of which method, but why did they pick that one? So Alyssa, yes, you will get to pick the method you want to use if no specific directions are given. But if I do give you a specific direction, then I'll want to make sure that you can demonstrate that method. But if no specific instructions are given, you get to choose. Ooh, Cody has given us a hint. Cody says, no angle is given. That means we have to use which method? What is it called? There's two different ways from this section that you could calculate your dot product.
We just do the components.
Yeah. So what is that called? Does anybody remember what that's called? You're going to use your components like Cody and Alyssa were suggesting.
I don't know the exact name.
All right. So if you look on, I'll refer you to the page here so that you know where it is. It's your definition for, it should be on page well, I'm not sure of the PDF, but if you have the textbook from Wiley, it is on page 163 of the online book. But definition 4, it is called the Euclidean inner product. So that is where you're going to go ahead and sum up the multiplication of the components. Now, your other way that you could solve it is, you are almost close. If you know the angle, does anybody remember how you solve it if you happen to know the angle between the vectors? So that'll be something you want to make sure you know for your exam. If you happen to know the angle between these two vectors, how would you then solve the dot product? Yes, sir.
Divide by the two. Oh, sorry, you weren't talking to me.
Yeah, go ahead.
You would use the norm of u times the norm of v times the cosine of theta from the angle.
Oh, yep, the angle between them. Yep, exactly. So those are going to be your two methods. All right, so we'll go ahead and we'll check out the answer here for 9. So here are your two vectors. They did not give you the angle, so you went ahead and used all your components. And so this is where we're at. So if you did the dot product of u times v, you'd be looking at, look at the components of u and the components here of v. So you can notice here, they're first multiplying the first component. So you have the 3 times the 2. And then they're adding that to the multiplication of the subsequent components. So we have plus 1 times 2 for our second components, and then plus 4 times -4 for our third components. And then you go ahead and sum all that up and you get -8. So what in the world would that tell you about those two vectors? What is that number then going to tell you in terms of information? Yes.
Because it's less than 0 to an acute angle.
Okay. And Anything else? And what do we call? So be thinking about what these numbers might indicate to you. You remember earlier what I said about what the dot product indicates? So if you looked at this and you saw these first two vectors, they have a dot product of -8. And then we have v times v has a different dot product. What might you conclude? Conceptually. All right, I'll let you think about that. See if anybody. All right, let's look at, okay. We had, I think, let's see how we're doing on time. Dun, dun. Okay. I think. Looking good on that one. Okay, so this is something that I would expect you to be able to do on your exam too. Okay. You want to be able to add, subtract vectors. You want to be able to solve for the angle between them. So how would you solve for the angle between two vectors? Based on what equations you might know, yes. So if we know the dot product equals, you said it before.
Yeah, the angle would equal cosine inverse
Uh-huh,
times the dot product of u and v
uh-huh.
over the product of their norms.
Okay. So you could actually go ahead and calculate that angle. So that might be something that you might be asked on the exam. So you rearrange those equations, you could solve for your angle between the two vectors. All right, so be thinking about that. All right, so last section, and then we need to go to breakdown. Okay. So the last section, 3.3, so is all about orthogonality. And lo and behold, they kind of start off here, where here you can solve for the angle between two vectors that's inverse cosine of the quantity, the dot product u times v divided by the norm of u times the norm of v. So something good to note, I will put it on the exam. So you'll want to make sure that you know how to rearrange these things. You never know, you might need to solve for theta as well. Now, what does it mean to be orthogonal? If you have two vectors that are orthogonal, what does that mean? Yeah, they're perpendicular. So those are going to be synonyms. And this chapter had some different concepts in here. And how do we know if two vectors happen to be perpendicular?
Zero's dot product.
Our dot product equals 0. So that's the other great thing, like you had said before, we can use that dot product to tell us if our vectors happen to be perpendicular. So if you go ahead and you use the component version of the dot product and you find that equals 0, you'd be able to conclude that they are perpendicular. Obviously, if you don't get 0, then they are not perpendicular. We also had something else they brought up, which was the normal. Does anybody want to take a stab at what that normal was? And why do we care about normals? What is a normal?
It's perpendicular to like the entire plane, basically, the line.
So we might have an instance where we have a plane And it might be for our purposes, it might be easier to describe that plane by its normal. So we have a very good indication of its slope, or we might have an easier way to describe that plane. So a lot of times we'll want to know the normals of our plane in question or our line in question. So it doesn't always have to be a plane. So we might want to know about these perpendicular norms. So here's an example of, here you have a norm to this line. Here's another example of this norm to this particular plane. So another very useful application for letting us know slopes. So the other thing is we also had the concept of orthogonal projections. And so here we have this vector u, and we might very well want to decompose it into a sum of w1 plus w2. So we might want to decompose it into its component vectors. Does anybody have some fun examples of where you might want to do that? Like, why would we want to decompose
Um,
into its vector components?
One's dot product.
I'll give you, you want to hear my two fun examples?
Sure.
Okay, so here's a fun example. You might need to look at two different properties or forces at the same time and know what the effects of each of them are. So if you think about an airplane taking off at a certain angle, well, you would want to know, okay, I might need to decompose that into, okay, what are the effects of lift versus what are the effects of drag?
Gonna have to.
So yeah, you got to make sure that plane takes off safely, right? We're gonna have to do that. Another fun example is maybe video games. And maybe, I don't know, you have some monster that all of a sudden moves diagonally, right? Well, behind the scenes, whoever's creating this game, you might want to break that into, okay, your X and your Y directions. And then it might also make it really easy then, in case you have some of your pieces, your game, I don't know, your game characters collide. It'll be easier to tell if they collide, so that maybe then you know, the monster ate the candy, or something should explode. So you might want to think about being able to describe directions really well in your video games, and what that means for your scenario. So a lot of cool reasons why you might decompose vectors into some component vectors. So we talked about two of them in this particular section. We have W1 and we have W2. So I do expect you to go ahead and know those equations for W1 and W2. Because you'll have this vector u, you'll want to decompose it into W1 and W2. And so they did in this chapter give you what those are called. So here we have, if we're going to decompose our vector u into W1, we've got a very, very long name for this, don't we? W1 is called the orthogonal projection of u on A. So if we go back and look at the picture. So W1 is the orthogonal projection of u onto this other non-zero vector A. So you're just dropping a line down from the terminal point of u down to A. And so they have this equation where you can calculate W1, and then your W2 is simply going to be u minus whatever you have just calculated. And that has a super long name too. So that W2 is the component of u orthogonal to A. Okay. All right. So if we go back and look at that, W2, yeah, I get that. It's orthogonal to A because it's perpendicular to A. So we can kind of see where they get some of these names. But do make sure that you know these equations, where to find them. I will give them to you on the exam, but you might have to decompose your vector into its components. So it'd be good to know how to do that. All right, so let's see what we got. 3:37. Okay, we are going to take a break, which I'm sure you all are ready for. And then when you come back, it's going to be time to work in your teams. Let's see if you can earn those bonus points. So the winner will earn bonus points, but all teams do need a participation. Sorry, you do need to participate for your participation grade, but our winners will get bonus points for the exam. So you don't want to miss it after the break. Okay, so we are at 3:38, so please be back promptly at 3:50. All right, I'll put that in the chat. Okay. So we will see you back soon, okay? Right, we are back. Da-dum-da-dum. Who wants to hear who the winner was of our encrypted messages from last time?
Yeah.
I'm not saying not us, because we kind of did a little bit late.
It was. You ready for it? Team one.
Who's team one?
No one knows who team one.
I
Okay.
have no idea what the name is.
Oh, okay. Nobody knows their team number. All right.
We're team two, right?
Team one was Dominic, Cody, Triharsha, Mahi. So that is our team one. So kudos to them.
What time did they submit it?
They turned it in very early evening. And they completed all the components that I asked for. Other teams were missing some elements in their work and answering the questions. So you might have gotten all 3 messages right, but you might not have completed the entire assignment. So team one is the one that completed all aspects of the question and got it in the fastest with all the stuff in. So good job to team one. So we'll see who does well today. So you will want to make sure that you gather in your team.
Wait, so what was?
If you are online, then you want to make sure that you identify your team. You know what team number you are, right? So hopefully you know what team number you are. Yes, sir.
Question one.
Yes.
Is that something that's gonna be like in the exam or no?
Is what?
Is the homework we did, that's not gonna be on the exam, right?
Not the message encryption, no.
Okay, Nicole.
Yeah, you don't have to worry about that on the exam.
Second,
But you might need to figure out inverses on the exam.
okay, but second, do you have like the answers of how, what the answer of for the cryptids? Or
You can come by and see me. Most teams got it right, so if you got it right, then you knew how to do it. But you can feel free to come by during office hours if you're curious about how to work that problem, for sure.
Okay.
Yeah. But let's see here. So hopefully you know what team number you are, because you might need to chat with your team members in your private team channel. Okay, so here's how it's going to work, folks. You will notice in your chapter 3 module, you have an assignment that is called 623 in-class participation exam 2 review trivia. So you will be working in your teams, and each person on the team needs to submit the answer to at least 1 question. So there are going to be 7 questions total. And we're going to try to mimic exam time. So you're going to have a certain number of minutes per question. So you're going to want to make sure that you're well organized. You figure out who's going to submit that question. The winning team will earn bonus points for exam 2. You have 5 people on your team. So everybody should answer at least 1 of the 7 questions. Some of you might have more than 1 question, depending on who knows the material better at this point. But everyone needs to answer at least 1 question and submit the work for it. So I should see work from each team member on how they achieve the answer. The other thing, because this is trivia, is that along with your solution, you need to submit your bid. Because this is gonna determine tiebreakers. So suppose you submit an answer, but you're not entirely sure if it's right. Well, then you'd want to put a low bid on it, right? So that you're not.
How much you start off with?
Yeah. So you can only, for each question, you can only submit 1 of these bids. You can only use a bid once. So one of your questions that you're really confident in, it will be worth $700. And then moving on down to 600, 500, 400, 300, 200,
What do you
100.
start with?
wait, we're getting paid?
You get to choose what you bid. It's going to be on your confidence in your answer on that problem, right? Have you done that with trivia before? So for instance, if you have 2 winning teams, it's going to matter on which ones they got right and like how much they bid on those ones they got right.
If you lose those points.
Yeah.
So do you start with 0 points?
Yes.
So you go in the negatives if you get everything wrong.
Yes. Yeah. So be careful what you bid. So you'll want to think about which ones you're confident in. All right. So everybody clear on what's happening? You're going to want to make sure you're in contact with your team. Each team member will submit question, and then some of you will be submitting more than one question.
Just messy.
But everybody at least has to submit at least one problem.
Seems like it's messy.
Perfect.
So, everybody ready? This is gonna be on a time limit, so you're gonna have about 6 minutes per question, cool?
Are you gonna be on here?
I'm gonna show them up on the screen. So let me get my timer ready. And are you ready for your first question?
You just submit like a PDF?
Yep. So figure out who's gonna do the work for it. You're gonna rotate around your team. Each team member is gonna submit at least work for at least one problem.
Are you guys okay?
A couple of you will be submitting more than one.
No. I can.
Up to you.
Submit, just want to put something
First, bro.
Yes.
We don't all use like.
She says some.
Yeah, so that,
It's fine.
however each team member does their work, they're gonna submit it to the assignment. Does that make sense? Yes.
Couple minutes for a sec, cause some of my teammates are online. Can we set up with Teams first before we start this?
You're gonna wanna make sure you chat with them in your team channel. Or if you want to, you can hop on your team channel if you wanna talk to them in person.
That'll be enough.
So you'll wanna have your headphones on that case. Don't wanna give any answers away.
Yeah, no.
So up to you how you coordinate with your online team members.
Teams.
Wait, but how are we gonna submit? No, is it in Canvas now?
Yes, so it's gonna be, you should find this assignment in Canvas. And you're gonna be submitting your work to this assignment, right? So are you guys ready for question 1?
Now?
Yes.
I'm originally online.
Huh?
Did you assign like groups via the Zoom for us to log in
Yes.
individually? Like,
Yes, so you should be able to have access to your private team channel. You should be able to only see the team that you're a part of. So if you chat on that channel, all that should be private discussion.
And then at the end, see which questions were.
Can you see your channel?
answered.
Yeah, so you can chat directly with your team members through there. Be like, hey, how do we solve this? Who's gonna turn it in?
I think it's actually great.
All that good stuff.
With your prize. I think it's great if you got it right or wrong.
Yeah.
All right.
This is why we'll do confidence. We'll see, do you think you got this one right versus this other one? We'll put ours on that one.
Yeah. So you got some things to decide. All right. Here we go. So this will also be a test of your coordination with your team. So here is going to be problem number 1 and go.
That's
I'm doing it again. Let's see. Probably next.
Okay, about 1 minute left, so you want to decide on a bid. Make sure you know who's gonna submit the work.
Oh. Good test. Yeah, I think it's too. You do beat them. You do beat. It's hard beat.
22.
And then negative 20.
You got that?
Negative 10.
I got negative 10.
I got -4.
Negative 10. Let's go with 10. There's 3.
All right, so somebody will want to submit the question work and the bid. Figure out who's gonna work the next question.
I think 200.
All right, so question number 2.
Lost stuff.
Do we submit at the end or do we submit right
Oh,
now?
you submit it. Whoever worked it has the work they're gonna show. That person needs to submit it. The next person on your team should start working this one.
How do we submit it?
I can.
On Canvas?
You reply to the post?
Yes.
This one.
So
Just take it. I don't understand.
Okay.
How much money you want?
send 200.
200 for 10?
You can only use the bids of even 700, 600, 500, 400, 300, 200. There's no 210 bid. And then there's 100.
I see like one submission, I'm confused. Like one box. where to put it.
Yep, so reply to it. And whoever is submitting the work, you'll want to reply and attach your work. And you'll put your bid in the comment box.
Period?
Submitting.
I'm submitting.
Yeah, he said he's going to submit.
So 1 minute left. All right, have your next team member submit your work with your bid.
I was 2 minutes.
Choose who your next person's gonna be. Even if you don't get the right answer, you want to make sure you submit what work you've done. Somebody needs to submit some work to show that you attempted it.
I don't know what submitting is. I'm so confused.
I took a screenshot, submitted the screenshot, and then put
Like here, I submit right here.
You can image. You can add an image to it.
I submit multiple times. Oh, okay, going to. I don't.
Yeah, all right. So make sure you've designated who's going to submit and who's going to put in a bid for this one.
I didn't even get close.
All right. Here we go, folks. We've got question
Let's just
number
put 100 on
three. Question number 3. 1 minute left. All right, make sure you decide who's gonna turn it in. And that you know what bid you're gonna make. All right, we are on to question 4, and here we go.
You can submit it.
What question is this?
This is question 4.
No.
I don't know, bro. That's a big one for me.
Got it.
So it's like 5 or 6 and simple. Okay.
Oh, yes, I got you.
4, 5, 6, and 7.
5 or 6, that's it.
5, 6. Tell me which one.
I got question 3. No, wait, it's not a question. Six. That's not that hard. Same. Guys, things.
Should be. That's pretty good. 7. Better go that way.
7, that's right, 74.
So you gotta use the distance one like that.
Wait, just curiosity, once you do all that, you add them together, then you square root.
Yeah, for the most part.
But that's kind of like a consistent between.
How the components. Did you know one? That's one.
Well, like sort of groups in case they have something else.
I'll chase that one. So Robert does. You guys know one, I just know one. There's those two.
I can submit this one because he did.
It was not, 7 questions, unless the number, but I'm pretty sure.
What did you get for? Two values that I get this.
The plus function
Subtracting the initial just to
13, negative 22.
subtract.
Yeah, I got it. Or I say it doesn't matter, bro. Do the fact that they're easy.
That's versus square. You have to add them, you get x, it's square root of
The distance formula is just square root of x squared minus x1 squared.
Yeah.
And then,
it's no way. 13. 13 plus. 26 times negative 26 plus.
you know how much you're asking.
You gotta square that.
Yeah. It's square after. After you do what's inside the bracket, that's cool.
It's like. Oh, yeah, you have, how would I square this? I know how to do this.
All right, now you put this, so these are x1, these are the x2s. Or component 2, so you have x squared. You have minus x1.
All right, 1 minute left.
Say that it's square.
I'll try to see how much the you get.
What's your answer again?
I can each bit amount once.
Page 600.
All right, decide who's gonna submit this one. Don't forget your bid.
What did you make?
Don't forget your bid, folks. You wanna win the game. All right, so one of you should be submitting the bid and the work. The rest of you are now ready for Q5.
No, separate.
Da, 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 da.
Oh, 21. Jeez, that's one. Like 20.
Q5. This is now question 5.
What do you got to?
Just a quick question. Would Andy's question be on the exam or no?
Similar ones.
You subtract.
I did it to
We're having some good practice.
This is 5.
Q5, folks. Q5.
There's 3 points you do. You take it.
Did you raise the yours?
I did last week. Subtract.
It's one of those, that's what I do.
All right, 1 minute remaining.
I need to submit this one.
All right, please decide who will be submitting. Don't forget your bid. They're really important for a tiebreaker and figuring out who wins. Don't forget the bid.
Submitting.
All right, decide who is going to be your final person to submit. Looks like we only have time for one more question, so there's only gonna be 6 questions total.
What is the 7?
Yeah, I know we're running around out of class time, so we only have one more question today.
I'm confident.
So are you ready? Here is your question 6. Oops, let's not do that one, sorry. All right, wrong one, Q6.
This one.
The B though.
This will be your last one.
W and U. See. Yeah, I know, but it's a fine. So. BB then. Hit the. Just don't know what's it. Where would B plug in? Excuse me? Can I ask you a question?
Yep.
On this question, is it projected WU? I don't see where would B be.
Uh-huh. It's worded a little bit differently, so you're gonna have to figure out from the equation they give you in the textbook, what do they usually put in the place of W or U? How would you apply that? Here you are projecting U along W.
Must be locked in.
Just work, yeah. I can't remember. I just don't know what I'm supposed to do with v is equal to. I don't know what it. I think it's kind of a little different. I only give you these two letters, which I get, but then this is the third one, so I don't know what the third one might be unless that would be times v. That's I'm trying to
Do I have to simplify if I'm multiplying a number by a fraction? Can I just put them next to each other to know that it's the product between them?
You want to simplify it as much as you can. I mean, you should have some sort of fraction or integer. You don't have to do decimal places, for sure. You can just leave it as a fraction. Or integer, whatever your answer happens to be.
600.
Yes.
Yeah, right, yes. I know, but I'm not asking where's v would be though.
One minute.
Substitute W.
600, yeah.
All right, folks, make sure you get in all your answers before class time is over. Keep in mind, this should hopefully give you a good judge on how much more you might need to study. Also for this one, did you need all the information in this problem? Do you need to use everything in this problem? All right, so just keep in mind, you're gonna have to decide on a question, what is the relevant information or not. All right, make sure you get in your answers and your bids. We're just doing the 6 questions instead of 7.
I got it. That was the easiest one. I was second.
About 3 of us got the exact.
So my recommendations to you all, please study. Please don't think that just because I'm giving you material on the exam means that you have all this time to look through the material on the exam and figure things out. You actually do want to study, make sure you know how to solve the problems that we went over, so that you can maximize your time on the exam. But like I said, you don't have to memorize anything. So if you didn't remember this equation exactly, but you should have a good indication of how to solve this. You might not remember the equation exactly, and you'll use the material in the exam to get your exact equation. And you should be able to calculate that pretty readily.
Quick question.
Okay, so that is that.
Quick question.
So please make sure you get those answers in, folks. Don't leave here without submitting your work. Yes, sir.
Well, that PowerPoint, is that in the campus or no?
No, I'm not going to give you the answers ahead of time, but I will post them later today. How about that?
That's what I meant.
Yeah, for sure. I will put those in there for you.
Well, where would that be exactly?
I will put them in your exam module, so you'll have it so that you can review. How's that sound?
You know what time?
No, it'll be sometime this evening. I gotta get back to my office. I have office hours, so it'll be sometime after that. So, do be on the lookout for it. Do make sure you have submitted it. All right, we are done, folks. So good luck on the exam on Thursday. Do make sure you practice. Go through all of the different problems on the study guide. And do review the problems that we did in class as well as the trivia. And you will be sitting pretty for that exam too.
I didn't.
I highly recommend that you do as well as you can on your first 2 exams. So then you do have the option whether or not you want to not take the 3rd exam. So then at least you'll have options. So don't blow this exam off. Yes, sir.
Which exam would you say is the hardest?
I would say probably exam 3, because now you're going to have to keep applying all the foundations that we've now set. So we've learned a lot about matrices, we've incorporated vectors, you've done a lot on determinants, and now it's going to start to come into play even more for chapter 4 and 5. So it'll be harder to do well on chapter 4 and 5 if you haven't been keeping up on 1, 2, and 3, right? So each exam is not technically cumulative, but it is really in essence all building on the concepts. So yeah. So definitely try to do well on this next exam. And you had a question, sir? You had another one, I think. Didn't you?
Did you just close the campus? Did you close this already?
Yeah, close at the end of class. So make sure you've gotten in your answers on that.
Is it like, do I still submit it? Cause I
What?
Still knows me, right?
What's happening?
Yeah.
It already closed.
It's a job.
You didn't submit it?
I'm still.
I think because we were going from problem to problem so fast, we were just gonna take photos of them at the end.
Yeah,
And
Oh,
just-
but then how do I know who got done fastest, and how do I know, because you might change your bids and stuff now that you know all the answers, or now that you know all the questions. So you were supposed to be submitting work along the way, right?
Yeah,
Because now you have an idea of which questions you're more confident on.
I don't think I need these questions. I was stuck on a few.
Yeah, that wouldn't be fair to the other teams who already submitted their bids, right?
I was trying to I was at least trying to do one question and that's it. I wasn't gonna do anything else.
What now?
I just feel.
All right, I'll open it for a few more minutes if you want to get your work in.
Which one were you gonna?
At least I was on that question.
The intention was to be submitting your work along the way, as I was saying.
I mean, I just don't know who submitted. Because I know you didn't yet, and I didn't yet, because I don't know who submitted.
All right, you have a few more minutes to submit, so please make sure you get your work in, okay?
Who submitted?
I've opened it up. You don't want to waste minutes now. You want to make sure you figure out who's got what work. And make sure you get that submitted, okay?
Right.
All right.
We should submit.
Jeez.
Okay, she only said do questions 1 through 6, not groups. 7. Oh, no, that was 27. God damn it. You didn't get 7. Even not getting 7.
Okay.
Good, so to-
Let's see.
Which one did you submit?
I think I did 5. Let's see.
I can do 2. I can do 2.
Okay.
I did 5.
So your exam grades are curved. If we have a ton of people who do well on exam, then the curve will either be 0 or not too much. So keep in mind, you do want to do well.
The curve will boost you, or does it sink you as well?
Oh no, it would never sink you. It would be only points added to your grade. I'm not gonna, yeah. I'm not gonna try to hurt your grade. No, I don't know why people do that, but anyway. You had a question?
I've never had an exam.
I'm sorry?
I never had.
Yeah, I opened it for several more minutes, so yeah, definitely get your work in. It's still saying close? I just changed it, but.
My curve will go down, but the teacher will take the wrong. I would do really good on the exam. and
Should be, you should be able to
I was
reply
just
to it.
decrease my grade. Like, okay.
You did?
well,
I'm waiting, it's one of my other teammates.
Oh, it's one of your other teammates. Okay. Just changed it to 50, so it was changed.
Lost.
Getting back to.
Sweatshirt.
That's 450. You have another one, get that in.
Question one, what are you doing on that elementary road part?
Became older, so I don't think I got to that part, bro. I did the first part.
It was.
Something about the box line.
I'm drunk, lunch, with this.
Birthdays and stuff.
This is why I have a person doing the same on the
Party.
You don't have to scan it.
I have to walk in and do this, so I'm like, bro, I'm ready for this. Oh,
I don't. Yeah. But that thing took so long to log in, all that crap.
Okay.
Log you out.
No, it does.
I'm sorry.
Let me,
I had to log in every time I do this.
Not using the rule.
Yeah.
Okay.
I think the certain rule ones,
They're
she
not,
has set to open on.
it's open.
This is closed for me.
Okay.